Welcome to question 4 of the year 10 end of year exam. This question is about atoms, right? Atoms. What does the number 19 represent in 19.9F? Right. Okay, look, you can see the answer I've written here. It is mass number. When we're talking about individual atoms, when this is referring to an atom, not a whole bunch of atoms, not an element, then the top number is not the relative atomic mass, not the atomic mass, it is the mass number, i.e. it's the number of neutrons and protons in the nucleus. So this is a massive trip hazard. So if we went to the periodic table and we looked at the number above here, say, which one is the fluorine? It said 19.0, this is an A-level periodic table, 9. Because this is the periodic table, this F represents the element fluorine, a whole bunch of atoms out in the wild. So this is the relative atomic mass, as it says in the key, because this is the weighted mean of all the different isotopes of fluorine. But if I'm just talking about one atom, and then there's no decimal, well, there wasn't one for GCSE anyway. When there's no decimal for the number up above, then it's talking about the mass number, the number of neutrons and protons. So this looked like a really easy question, but actually it was super sneaky, and I think maybe 5 people in the year got it correct. How many atoms are present in 1 mole of fluorine? So this is just a simple recall question. This is asking you to remember Avogadro's constant. Avogadro's constant is 6.02 times 10 to the 23. Do you have to remember it? It would appear that you do. The plum pudding model of the atom was replaced by the nuclear model. The nuclear model was developed after the alpha particle scattering experiment. Compare the plum pudding model with the nuclear model of the atom. There is our command word. We need to be making a comparison. A comparison consists of noting the similarities and the differences as discussed before. So look, I've made it super easy for the examiner. I've split my answer into 2 columns. I'm going to list the similarities and I'm going to list the differences. First of all, what is the same about them both? Well, I said that both have positive charges. If you remember, the plum pudding model is basically a ball of positive charge with negative charges embedded in it, like plums in a plum pudding, but you've never seen a plum pudding because, yeah, I mean, I've barely seen a plum pudding and I'm 46. Both have negative, so, and here's a nuclear model, sorry, it's a simple nuclear model, there we go, nucleus in the middle, got positive. Both have negative charges, yeah, there's a negative charge of the nuclear model, there's a negative charge, the plums in the plum pudding model, blah, yeah. Neither has neutrons, right? Neutrons weren't discovered until 1930s. They were the last particle to be discovered. So these 2 early models don't have neutrons. There we go, there's all the similarities that I could think of. Now I'm going to go on to the differences. Plum pudding, brackets PP, so every time I refer to the plum pudding model after that, I can call it PP because this is my abbreviation for plum pudding because, time's money. Plum pudding, PP, is a ball of positive charge, there it is, with negative charges embedded in it, there they are. Whereas the nuclear model, brackets NM, has positive charge at the centre, there it is, with electrons orbiting, there they are, well there he is, orbiting like that. The plum pudding model has no empty space, it's all gubbins, it's all a ball of positive charge with electrons embedded in it. But the nuclear model, most of the atom, this bit here, this stuff in here, is empty space. Right, there is loads more than 4 marks there, but